Okay, this is Module 11, Fluid Mechanics. Let's go. So fluids are everywhere. Essentially, we are living inside a fluid. Like for example, the atmosphere itself, the air, it's a fluid. So you have like typical na fluid na to na masabtan is like kanang water. It's a fluid. Pero ang hangin pod na sa atong palibot is a fluid. The air we breathe is a fluid coming in and out of our bodies. Ang kanang, yeah, yeah. So we are in an environment that is full of fluid. Gina-compress lang na to, gina-expand lang na to, and we are now in full fluid. Okay? So, ang goal nato is like we're gonna try to understand ang iyang mechanism sa fluid as it moves from one part to another part. So, ang mga motion niya, ang course, pag motion, you also have to tackle about yung mga energies o kanang nganong kanang sa gripo, paspas or hinaingdagan sa tubig. Okay? So here we have the first topic is ang pressure, density, and specific gravity. So pressure, so siguro makadungmuan na, is kanang defined to be a force per unit area. Force per unit area. For example, ang kanang book, let's say ang book imong ibutang sa surface or sa imong palm, you will feel that there is a force covering that particular surface area sa imong palm. Same as kanang gamay kay nga needle, kanang like kaning figure nga na diri, kanang gitusok sa panit. So yes, you can see gamay kay nga needle being applied to a small area. Makita nimo na of course kanang nganong dali ra ka siya makapenetrate. Even though gamay ra nga force na kinahanglan. Unlike say for example, let's say kaning block or kanang greater amount of force like kanang isa ka kilo nga bugas ibutang sa imong hand, nganong dili man niya ma-penetrate ang panit sa imong hands. So it's because of pressure. So here we see that ang force na gina-applied here is being ginaigo ang gamay kay nga area sa imong panit. So you don't need a lot of force in order to penetrate, in order para matusok ang imong panit. Okay? Kani po siya, like for example, naka isa ka block, let's say kahoy ni siya na medyo bugat-bugat, maka-experience po siya og forces sa iyang surrounding, sa iyang kilid, sa ubos, o slightly kanang sa taas. Okay? Pero the difference is that mas bugat kaning naa diri sa ubos. And ma-feel na nimo if you go swimming. If you go swimming, ma-feel nimo na naay ka ng murag compress ang imong lawas because of the force being exerted all around you. Kung maligo kag dagat or of course kung naka sa gawas sa pool, you feel like wala lang pero naanad na kaana. If suddenly mawala ang kanang forces around you like while walking, you'll feel different kay walay nagapugong. I don't know what would happen. If it's a good thought experiment. What if mawala tanan fluid sa atmosphere? Okay, or mawala ang atmosphere essentially. How would that change sa imong body? The unit of pressure is called Pascal. Apelido ni siya Blaise Pascal. 1 Pascal is equal to, or 1 PA, yung notation, is equal to 1 Newton per meter squared. So Newton, if you remember, is a unit of force, and of course m squared is a dimension related to area. Here we have what we call the atmospheric pressure. This is the pressure on Earth's atmosphere. Okay? At sea level, the normal atmospheric pressure is 180 m, short for atmosphere. It's given by 1.013 times 10 to the 5 Pascal. That is the atmospheric pressure. So somewhere here siya. So you can see, pag magka-siya, manotice ni mo from 100 or 1.01, magka-reduce ang pressure niya So from 101, may mo siya 31,000. Then here, at some point, wala na. Zero na ang iyang atmospheric pressure. We also examine ang kanang ang kanang molecules, air molecules. So at the sea level, you have high concentration sa imong air molecules. And once musaka ka, magkagamay and eventually maggamay din sa outer space sa dayon. So ang tendency, like for example, ang kaning like mga plane, they would tend to go higher at some elevation para dili kay nga naka-turbulent. Dili ka turbulent. Sometimes it's above sa clouds or within sa level sa kanang slightly higher than the clouds. So kung maka-experience mo turbulent kayo, most likely you are passing through high molecule na atmosphere. Okay, let's go. Density is an intrinsic property of a material. So intrinsic meaning naagi na siya always sa isa ka material. Mathematically, we know density is the mass per unit volume. Okay, so you have here the unit of density is kilogram meter cube. Volume man siya, kilogram meter cube. In CGS unit, it is gram per centimeter cube. 1 gram per centimeter cube is of course equal to 1,000 kilogram per meter cube. So yung system international na description. Okay. Specific gravity relates to a relative density. Relative to unsa? Relative to the ratio of the density to the density of water at 4 degrees Celsius. So you have 1,000 kilogram meter cube. That's the density of water at this temperature. So this is the density of material, of any material, with respect to the density of water sa kaning temperature, 4 degrees, na siya 1,000 kilogram meter cube. Okay? That's the specific gravity of or relative density. So we look at the different densities of a material. So air has a density of 1.2 kilogram meter cube. Okay? And if you look at here, nagkagamay siya. Ethanol, 0.8. Benzene, 0.9. So, the lower the density, mas mo float siya above. And you have ice, 0.92. Water is 1. Okay? Ang seawater is 1.03. Mas bugat-bugat siya. Ang blood is 1.06. And so on. Ang concrete is of course quite high. Ang aluminum, so on. So, typically, if you look at the densities, lain-lahi gid siya. Like, that's actually one way of determining unsa ang material nga naadira. One way, yeah. Like, obviously, ang gold ug ang iron are quite different. Another way is kanang sa pag-design sa kanang mga drinks na usually, ngano ang ice mo lutaw man siya. If you look at ice, 0.92. So, mas gaan siya compared sa mga typical na alcoholic na mga drinks. Yun, okay? 0.92. Yeah. Wait here. So, mas gaan ang ethanol. Mas gaan siya compared sa imuhang water. Okay? 1. So, typically, mulutaw siya sa ibabaw. So, in this example, you have different, let's say, different liquid materials and mag-separate siya because of the difference in density. Of course, pinakabugat na adiri, pinakagaan na adira sa taas. Okay? Pressure variation, absolute pressure, gauge pressure, and Pascal's law. So here we have an object immersed in a fluid. The top and bottom part will experience variation in pressure. So if we look at this figure, ang F-top ni Muha, let's say kung naka-immerse siya in a liquid, the number of particles na nasa ibabaw is different sa nasa bottom. So ang kuwan po niya, consideration po nimo ang sa side, kaya naman siya side. Luckily ang sa side kaya they would cancel each other out ang kaning mga forces nga naadiri. Let's say Fs. Pero ang top and bottom, dili sila basta-basta cancel out lang. Kaya, yeah. And you also have the weight because you still have this mass here. So, interaction with the gravitational acceleration. So, ang imuhang equation that would describe this phenomenon is negative F top because it's going downwards and F bottom going up minus the weight going down. So, using the equation and the expression for pressure, P is equal to force over A, we can now write this equation 4 into something na ma-relate na to ang pressure sa forces niya. Ha? So looking a bit more detail, you have, let's say, if we assume that this mass here, nag-float siya, ang iyahang F top is nasa inline sa kanang surface, ang F bottom nasa ubos, siya weight. So we can redraw this one into a point at the top and point at the bottom. These are pressure at the top and pressure at the bottom. So naa kay elevation, this is ang kaning Y1 is the height from the some relative base nimo ha, og ang Y2 is kaning nasa distance to the top. Ang top nimo is exposed to the atmosphere. So ang pressure at the top is actually the atmospheric pressure denoted as P naught. Dili not na NUT but NAUGHT, P naught. So P bottom ang kaning pressure nga naa diri na point at the bottom. So we recall the expression for the pressure, force over area, and we also recall the expression of the density, which you know as the mass over volume. And the equation 4 wherein ang weight is transposed on this side, so may mo siya positive weight. So we now try to substitute this. So ang weight is just mg, ang F bottom. So we can rewrite this one as pressure is equal to force over area. So pressure at the bottom, area at the bottom. And then similarly sa top ni mo ha, ato lang siya move here. So pressure at the top, area at the top is equal to V rho density G. Because mass, if you remember, if we rewrite this in terms of the mass, that's cross lang siya. Rho G na siya. Okay? Okay. Now, if we assume na ang object has the same surface area sa top at sa bottom, so area at bottom, area at the top will be the same. Okay? So A lang siya. And we also recall that the volume is equal to length times width times height. Ang kaning length times width is equal to the area times height. So if we assume also, well, we don't need to assume because we know that this is the same mass. So they have the same na area. So from here, we can cancel out the areas. Okay, so P bottom is minus P top is equal to rho GH. But remember, ang P top ni mo, pressure at the top, is equivalent sa atmospheric pressure P naught. So P minus P naught is equal to rho GH. So when H increases, the pressure also increases. Ang G constant naman siya, ang density is also constant if the same na material. So nag-vary siya based sa height. So that means kung magkailalom siya, mas mo-submerge siya, mas magkadako ang height difference, then you have greater pressure at the bottom. Which is true kay kung say mo dive ka sa water, magkailalom ka, you feel this pressure pressing sa imong body pressing sa imong body because there's a larger mass on larger amount of volume of water na nag-surround sa imo, especially if you go lower. Now, if we consider the surface of the Earth as the position for the atmospheric pressure, so P naught is the atmospheric pressure, the P there is the absolute pressure, and rho GH is the gauge pressure. Okay? Dependent siya sa unsa siya kalalom ang iyang ma-reach. Okay? Saka, difference sa height yung ma-reach. Now, let's look at this example. So you have a water reserve with a height of 12 meters deep in a storage tank whose top is open to the atmosphere. Open to the atmosphere. So meaning the top pressure is the atmospheric pressure. What are the absolute and gauge pressure at the bottom of the tank? So we note that the tank is open at the top, so exposed to the atmosphere. So the top would be P naught, which is 1.01 times 10 to the 5 Pascal. Take note, the condition is that open ang top. Pag sirado na siya, lahi na po na siya na scenario. So, the gauge pressure is easily calculated, which is simply rho GH, the density times gravitational acceleration times height. So, the density, water tank siya, we'll assume water ang nadra, is 1,000 kg per meter cube. Times acceleration due to gravity taken as 9.8 times 12. So the gauge pressure is 1.18 times 10 to the 5. So the absolute pressure, if you remember, is from the expression P minus P naught is equal to rho GH. So i-transpose lang nimo ang atmospheric pressure on this side. So you get this expression. So which is just the sum of the atmospheric plus the gauge pressure gives you the absolute pressure of 2.19 times 10 to the 5 Pascal sa height na 12 meters na deep. Okay? So mag-vary siya if it goes lower than 12 meters or a bit higher than 12 meters. Okay? Here we have another example, which is a manometer. Manometer tube is partially filled with water. Oil which does not mix with water is poured into the left arm of the tube until the oil and water interface is at midpoint. Sayo pang drawing baliktad. I mean anyway, it doesn't matter. Basta nag-separate ang oil o ang water. Both arms of the tube are open to the air. So meaning this one is open to the air. This one is also open to the air. Which gives you an idea that the top part niya is atmospheric pressure. Okay? Find the relationship between the height of the oil and water. So duha ni siya ka-liquid. So we have to write two expression of the pressure. You have the pressure, absolute pressure for the water and for the oil. Okay. Both fluid columns have pressure P at the bottom. So kani siya. They have, it's at the bottom. P na siya. Same sila pressure na experience at the bottom. And are both atmospheric pressure at the top. So P naught here, the second, they are both at atmospheric pressure. So this is the same as this, and this one is obviously the same as this. Kay open man ang top nila ha. So P naught plus rho GH for the water is equal to P naught plus rho GH of the oil. So this one cancels out. So that means this is now the relationship of the water na density times height is equal to the density of oil times height of the oil. So that is the expression there. Okay. Next, Blaise Pascal, which is the author's Pascal's law, which states that pressure applied to an enclosed fluid will be transmitted without any change in magnitude to every point in the fluid and the walls of the container. The pressure at any point of the fluid is equal in all direction. Okay. So if you look at here, we have like a device used to lift cars. It's one of the applications practical applications of Blaise Pascal. So let's assume here this is a pressure applied to an enclosed. Let's say this is an enclosure, transmitted undiminished to every point of the fluid in the wall. The containing vessel is the vessel. Kaning red, this one is the fluid. So let's say connected by a tube. Okay, by a tube here. So if you apply a force here, syempre makompress ni siya, this one would extend upward ang force here and vice versa. Okay? Take note that according to the law, Pascal's law, is that the pressure exerted here is the same as the pressure exerted here. And we know that pressure is equal to force over area at P1 is equal, that means equal po siya sa force over area for the second point. So we can equate the two expression and we arrive to this equation here, equation 6. Okay, so the ratio of force of area at point 1, this point here, is equal to the ratio of force and area at this point here. Let's look at this sample problem. So a barber raises his customer's chair by applying a force of 150 newtons, this one here, F1, to a hydraulic piston of an area of 0.01 meter cube, this one here. If the chair is attached to a piston of area of 0.1 m squared, how massive a customer can the chair raise? So assume that the chair itself is 5 kilograms. So 5 kilograms plus the mass of the person. So if we use Blaise Pascal's law, that the force over area at this point here is equal to the force over area at this point here. So rewriting the force exerted here, F2 by F1. So F2 is equal to area 2 over area 1 times F1. So F2 is 1,500 newtons. But that is the weight of the person, or that is the force of the person plus the weight of the chair. So weight of the person is just simply the total force minus the weight of the chair. So 1,500 newtons here minus the weight of the chair. So the value of the weight of the person is 1,451 newtons. The question is how massive customer can. So it's talking about its mass. So from the expression, weight is equal to mg. So m is just the weight of the person over g. So 1451 newtons divided by 9.8 gives you the mass of the person, 148 kilograms. Kuha nga tao eh. Okay, let's go. Next is ang buoyancy and Archimedes principle. It's a interesting property ni siyang buoyancy because metal has a higher density. We would expect it to matagak siya sa water. Here we know that metal ships are bet sa inyuha, nakasakay na mo, even planes na mas clearly mas bugat siya. Of course, a plane is using thrust, but for boats, you can see these metallic ships are able to float. They're able to float because they're able to modify the density of the ship, not the density of the metal, the density of the ship, because mag-create siya ka ng mga compartments inside. So thus changing the density of the ship, allowing mga air pockets everywhere sa ilalom. So this is Archimedes' principle. When a body is completely or partially immersed in a fluid, the fluid exerts an upward force on the body equal to the weight of the fluid displaced by the body. This upward force is called buoyant force. So kung kabalo mag-float, kung di mo kabalo patudlo mo. Kung magkabalo mo mag-float, mabantay nimo na you are able to lie down sa kanang tubig. So you would experience a force na goes against sa imong weight. So it says here, kung imo siyang, for example, kaning block, literally block na block, pag imo siyang itagak, there's an amount of water na ma-displace. And this amount of water na displace is equal sa weight sa fluid na na-immerse. Okay? Na-immerse. If partially immersed, katong partial nga immersed na weight. So, it's, and with this one, it's able to calculate ang mga volume o density sa even mga na material. Irregular shape na material. So, let's examine this one. So, let's say we have this block of mass, gitagak siya into the water o na water na displaced this one here. So, you have the forces and you have the difference in elevation. So, the magnitude of the net force along the y-axis is due to the fluid, which is the buoyant force ni siya. So, the buoyant force is the difference of the force at the bottom minus force at the top, which is equal to W or the water, this water here na displaced kana siya. So, and we know water W or weight W is just mass of the water displaced times gravity. And we can further expand ni siya using the expression of density is mass over volume. So that means mass is equal to density times the volume. So hence mo na siya. This is for the water displaced times G. And we know the volume, of course, volume is length times width times height, and we can simplify this as area times height. So we have this expression here. So H is the height, this one, height of the, no, not this one. It's this one here. It's the height of the water displaced. Okay, this one is different. It's the height of the water displaced. So FB, the buoyant force, is equal to the density of the water displaced, or the density of water, times the area times the height difference. Height difference. What is that? There's something wrong here. No. Yeah, H2 minus H1. No, it's this height. It's this height here. So it's Y2 minus Y1. Y2 minus Y1 as an expression. So the density of ice is 920 kilogram per meter cube. What fraction of the volume of ice will be above the water when floating in fresh water? Find the ratio of floating ice over ice total. So nagitagak na ice, na siya density sa ice, which is different sa density sa liquid water. So na kay buoyant force upward, o na kay weight sa ice total. Okay? First step is we examine the forces along the y-axis. You have the buoyant force minus a weight ice total, which is equal to 0, reach equilibrium. So we can transpose this one here, so we get this expression here. So we recall the expression for the buoyant force, which is equal to the weight of water displaced. So perhaps na siya dira ang weight water displaced. So this is the density of the water displaced times the volume of the water displaced. Let's say this one here, this volume here, okay, which is the difference of the volume of the ice total minus the volume of the ice na nag-float. Okay, this is the ice na nag-float. Okay, times G. Then we substitute equation A to equation B, this equation A. So the water, the weight of the ice total, this one, weight of the ice total is equal to the density of the water, ice total, minus V ice na nag-float, density of this one, density of ice, V ice total, G. Okay, so we have this expression here. We equate the two, this expression to here. So weight sa ice total is equal to the density of water, V ice total, minus V ice that floats. So we know this one as density ice total, V ice total is equal to the density of water in this expression here. And we arrive to this expression here. What do? We simplify the expression by dividing, by crossing this density of water here and this one here at the bottom. So this is now the ratio of the ice density of ice over density of water. So this one cancels out. So 1 minus V ice that floats over V ice total. And V ice that floats is over V ice total 1 minus the density. So it's more math. So bantay lang ninyo class ang pag substitute. So if we solve this value here, ang ratio sa V ice that float over V ice total is 0.08. Okay, 0.08. Next is ang fluid flow, continuity equation, and Bernoulli's equation. So here we have two figures, turbulent flow and streamline or laminar flow. So kung naagi mo ka ng mga rivers, usually kay shallow lang ang rivers, meaning ang gamay rag tubig mostly kuan siya. Violent ang behavior sa tubig because of the rocks. The rocks na nasa bottom. So ang model niya would look something like this. Very turbulent siya. Yeah, maganda turbulent flow. Ang laminar flow is usually ka ng mga deep na mga lake na kalmado ra kayang tubig. So ang model niya would look something like this. Ang dagan sa iyang tubig, sa iyang fluid. Okay? Application of understanding fluid flow is we can imagine if you want to go really, really fast in certain different fluids, like for example in air. This is also typically in air food, and this one is in water. By reshaping the shape sa imuhang vehicle, like they all have similar na shape. Pointy, medyo pointy ang ilahang front. This is to be able to cut through the fluid and to be able to move faster. Okay. Fluid flow at various objects. When fluid passes through a chamber na siya object, the shape of the fluid changes. Like for example, this one. This is stationary. Stationary in a sphere, and you can see how the fluid interacts. Here we have a different shape. Sa fluid, again, stationary. And you have the behavior of the fluid. Here, it's actually, this one is like a cross-section, it's like a wing. So as the fluid goes in, you can see that there is a much separate ang distance niya diri compared diri sa ubos. This one, it seems like compress niya ang sa ubos. Thus, this design allows greater na lift. Here we have a moving na sphere. As you can see, there's a turbulent na aspect niya when it rotates, disturbing the direction sa imuhang fluid. You have a streamline, then suddenly, because of this motion, it disrupts the flow of the fluid or the liquid. Here we have what we call a flow tube. Flow tube is just like this pipe here. Ang flow tube na kay duha ka nagvary, it's varying size niya. This one is a greater area compared to this one. And here we assume that the liquid or the fluid is incompressible, meaning dili siya mo change ang iyahang volume no matter how much we try to compress it. The product of area times the velocity of the particles as it moves is constant siya, and there's no change in the pattern of flow, is what we call a steady flow. Stream or flow line, the curved tangent, this one here, this dash is tangent to the direction of the with the velocity. Okay, so we see ang fluid nagapass through siya from here, then it goes out here. So over the same period of time, nagamove ang imuhang particles. Okay, so let's go. For an incompressible fluid, we have this expression that area 1 V1 is equal to area 2 V2. This is the continuity na expression. The product is the volume of the flow rate. So that's dV over dt, at which the volume crosses a section of the tube. And so that means here, kung dakong area here, ang velocity niya would be smaller. Then here you can have a smaller na area, ang velocity would be larger just to balance out. Okay, dapat the same raman ang ilahang rate. Okay, the mass remains the same based on the law of conservation of mass, the amount of masses niya as it moves. So we recall the expression of density, mass over volume. So the mass is the density times the volume. The rate of change, dm dt is equal to dm dt. Constant ang rate niya of change sa iyahang, ang rate sa imong mass. Okay, so dm1 dt is equal to density derivative of this one, rho v1 dt. Okay, which is also equal to this one, this expression at these two different point A and point B here. And let's say the same number sila fluid, so the same na sila nga density, and we can factor out ang densities here. Okay, so you have rho 1 here and rho 2 here for the different points A and B kanisha. And that means ang imuhang volume is also expressed as this area times the length, ds, ds1, ds2. And they're not the same ang imong area, kay kanisha larger compared to this one. So dm over dt is equal to dm over dt here. But this one here, this is length over time, gives you the expression for the velocity. This velocity here and this velocity here. Since dm1 over dt by conservation of mass is equal to dm2 over dt, so we can equate the two expression. Okay. Why is it density 1, density 2 here? Ganun di no lang isa. I think we are trying to incorporate what if makompress ni siya. But for incompressible, they should be the same. Yeah, see? For incompressible na fluid, ang density nila the same lang. So ang imong rho 1 o rho 2 is cancels out. For compressible na fluid, they have different density when it reaches a much smaller nga volume. Okay, so incompressible and compressible na scenario ni siya, na continuity na expression. Now, Bernoulli's principle. So we're gonna talk about energy. States that the work done on a unit volume of fluid by the surrounding fluid is equal to the sum of the changes in kinetic and potential energies per unit volume that occurs in the flow. So you have energy at point 1, energy at point 2. So of course, mas higher ang position sa energy at point 2, so na siya potential energy due to gravity na much comparably different. So let's look at the work expression. So we know that the work expression is force times the distance. So the work here is the difference of F1 D1, F1 or S1 minus F2 ds2. So the force here is the force is equal to from the expression pressure force over area. So that means force is pressure area. So you have this expression here. Similarly sa imong F2 pod. Since the fluid is assumed to be incompressible, so ang volume here, dV1, is equal to dV2, which we denote as simply dV. And dV is equal to area times the length. So ang imong work for incompressible is given as a function of this. So you have the pressure changes kay ang dV ma-factor out man mo. Okay? So this is the work. So considering points AB or point 1, points AB kanisha, dV is equal to dV1 is equal to area 1 ds1. And remember, this is also an expression for dm. Okay. Because you remember, density is mass over volume. So that means mass is rho dV. Since the density is the same, so we factor out, and that means ang imuhang dm is you multiply this one by density and you have this expression here. And dm is equal to the area times the length ds1 times density. So thus the kinetic energy at points AB, if you remember, kinetic energy is equal to 1/2 mv squared, and we know that the mass here is dm. Substitute here, so 1/2 dm1 v dot v, and we rewrite this one as this expression. So you have it here sa imong differential na kinetic energy. Now, if we have this one at points AB, we can consider point CD, this one here. So dV again is equal to A2 ds2, area 2 ds2, and again dm from the expression of density is mass over volume. We can rewrite that one. The dV will simply multiply that one by the density. Then from here, we substitute this to this expression here, we get this one. dm2 is equal to A2 ds2 density. And we substitute this mass here to the kinetic energy expression. So we have this expression for dk2. So we now have the two kinetic energies at points 1 and points 2. Thus, at points 1 and 2, where the total kinetic energy is simply the difference of the kinetic energy at point 2 minus point 1 at point 1. dk1 is given by this expression, dk2, which can be written as this one and this one. So the dk total is just 1/2 rho dv quantity v squared minus v1 squared. Okay. So considering the potential energies at points 1 and 2, which is, if you remember, is just mgh na siya from here to the center of mass siguro na siya. Yeah, center of mass. Sa disk ni mo, which is given the potential energy mgy1 y1 and mgy2. Okay. So du total is just a difference of the potential energies, which we can factor out as mg quantity y2 minus y1. And m, if you remember, is just rho v, and ang density, let's say constant siya, ang volume na niya ang differential equation. Okay. So now we have the expression for the change in the kinetic energy total, the potential energy total put, and we have the expression here. Then we can go back sa expression sa work, and which is just the work is just the sum of the kinetic energy total plus potential energy total. And if we substitute this expression work ni mo, you have this, and dk total, this one, and du total, this one, and this one. So substituting, you arrive to this expression here. Okay, so you have different parameters na dire, and we can use this one for different situations. Okay, now like for example, if the fluid is at rest, so walay movement, so the velocities are 0. So from equation 13, this cancels out mga velocities, and we are left with this expression P1 minus P2 is equal to rho GH, which is the, if you can say, we can say gauge pressure minus atmospheric pressure is equal to, no, absolute pressure minus the atmospheric pressure is equal to the gauge pressure, equation 14. Now let's look at this example. Water enters a house through a pipe with an inside diameter of 2 centimeter. Okay, at an absolute pressure, take note, this is absolute pressure of 4 times 10 to the 5 Pascal, about 4 atm. Then 1 centimeter, this one, pipe leads to a second floor bathroom, 5 meters above ang height niya. When the flow speed is 1.5 meter per second, when the flow speed at the inlet pipe, so meaning at this one, find the flow speed, pressure, and volume flow rate in the bathroom sa outlet, which is ang may diameter na 1. So for letter 8, to find the flow speed, we use the continuity equation to solve for the outlet. So incompressible ang assumption nato sa iyahang fluid. So area 1 V1 is equal to area 2 V2. Kung non-compressible siya, na siya density here. But luckily, wala. Okay. So rewriting this expression to solve for V2 here, V2. So it's area 1 over area 2 V1. So we know that the area, so pipe man siya, so ang iyahang area is pi r squared. So you have this. So the pi cancels out. And radius is just the diameter over 2. Okay. That means 1/4 will cancel out. And you are left with this for V2. So the diameter at the diameter 1, which is 2 centimeter over sa outlet 1 centimeter. So this one is 1. So 4 times 1.5 gives you 6 meter per second. This is the flow speed at the bathroom or the outlet here. Okay. For letter B, let's for the pressure at the outlet, we use Bernoulli's equation for fluid. So if you remember, Bernoulli's equation is written as pressure 1 plus rho gy plus 1/2 rho v squared is equal to pressure 2 plus rho gy2 plus 1/2 rho v2 squared. So we have to find the value for pressure at point 2, P2. So we write the expression to solve for P2. So we can transpose rho gy2 to this side, so hence negative siya. And this one, 1/2 rho v2 squared to this side, so negative po siya. And we can combine some similar terms, this one and this one. You get this, and this 1/2 rho v squared and this one. You get this. Now, we have an expression na pwede nato i-substitute ang mga given values. P1, which is the gauge. This is the absolute, not the gauge. This is the absolute pressure at point 1, 4 times 10 to the 5 pascals, minus this expression here. So if we look at this one, is rho gy2 minus y1. This y2 minus y1 gives, according to given, this is 5 meters. Okay. And this V2, solved not earlier, which is 6 meter per second squared, minus the inlet na speed, 1.5 meter squared. And if after substituting, we solve it. And of course, we arrive to the pressure, point 2. So this is the absolute pressure at point 2, 334 125 Pascal. Okay, so it's comparably higher because this one is like 1, 2, 3, 4, 5, 6. So 3.3 times 10 to the 5 Pascal. 1, 2, 3, 4, 5. Pare-pare, 3. Yeah. I see. Gamay na siya. Yeah, nigamay siya at 0.2. Is that right? Now the flow rate is given by the equation shown here. So the flow rate is just the rate of the volume, dV over dt, which is equal to area times V. So dV over dt, which is constant, is equal to area 1, V1 is equal to area 2, V2. So we have here pi R1 squared, because it is the area times the velocity 1 or 2. So for this case, R1 man siya, so we choose V1. So pi D1 squared, D1 over 2 squared times V1 gives you the flow rate of 4.7 times 10 to the negative 4 m cubed, because this is volume per seconds. Okay. Now let's talk about viscous fluid flows. Smoke produces a laminar at the bottom. This is laminar-like, and reaches a certain height, it becomes disorder. So turbulent siya. The difference between the two types of flow is due to fluid friction or fluid friction. So external factors can also nature can also affect the nature of flow, such as the surrounding environment, and it can produce turbulent flow. So here, if you have a smooth na bottom, typically smooth pa ang flow niya. If you have a rough na bottom, it would change the behavior of the flow niya. Surface tension is the spreading of tension across a surface of a certain liquid. So in this figure, na kay water strider kanisha. And the surface tension is caused by the nature of cohesive forces acting on the surface, because of they tend to compress ang mga molecules nga naa dira. They will tend to attract towards each other. So na siya mag-create siya more siya kanang elastic membrane. So lahi ang kanang nasa surface. Although the same na composition, lahi ang behavior niya structurally pag nasa surface compared na sa bottom. This member is an interface developed when a liquid is in contact with other liquids, which has gases. Like for example, you have water at the bottom, then you have air at the top. So it would tend to create a much more compact na behavior sa surface. Electrostatic interaction on surface tension. Force total acting on the molecule at the surface is non-zero and directed onto the liquid. Force total of the molecule is zero as it experiences an equal amount of force that cancels each other. So as you can see here, you have the force total here is not equal to zero, because forces tend to be directed sa fellow niya na water molecules. Okay? Pero at the surface, which is air, let's say air siya, dili. Pero pag nasa sa bottom, you can see that the forces total is zero. It's surrounded by other fellow na water molecules, and thus canceling each other. Okay, so non-zero sa surface and zero sa kung submerged siya. Okay, the surface of the liquid is covered by a stretched na membrane. Okay, let's say here. Okay, where the molecules hold together and reduce the area as much as possible. So meaning magka-compress siya. Surface tension can be reduced by increasing the temperature. So mo nang kung mulutaw ang sa ka-object, let's say a needle on the surface, an undisturbed na needle, kung imo i-increase ang temperature, ma-disturb siya. So ma-disrupt ang cohesion na nasa surface, so malunod siya. Okay? So basically, ma-unstable ang water molecules. Surface tension calculation. So there's a device actually na ginagamit to measure ang surface tension. So let's say this one is, let's say kanisha, this is the water, thin water, nashay certain parameters. You have the length d along which the force acts. I may have made a mistake here. This is soapy water. So nakay weight ni mo, o nakay tension slider. I think this is a slider. Okay. So the horizontal slide wire, this is a wire, is in equilibrium under the action of the upward surface force. So this is the upward surface force. The amount of force that can be measured by balancing this tension here. So That's how you measure the surface tension. This parameter here, gamma, is an expression of the force over the length d along the force axis. Okay. Here we have the different values for the surface tension. So you have the surface tension nagabari, or for example sa helium very gamay. Pinakadako dire here is it 75? And this is for water. Napalit mas dako 465. Mercury. So mercury in liquid nga form, which is normally at the temperature 0 to 20 degrees. You can see here. So here we have a needle that has a length of 3.2 centimeter. When placed gently on the surface of water, na naa siya'y gamma of 0.0173 Newton per meter in a glass, this needle will float if it is not too heavy. What is the weight of the heaviest needle that can be used in this demonstration? So if we assume na kani ang behavior sa shape sa water surface, kani is the cross section of the needle. You have forces F1 here and force F2 here. You have the weight of the needle pababa. So if we draw this sa yung FBD, so you have F2x, F1x, and you have F2y, F1y. So F2x and F1x will cancel each other. But what you have here is ang imong F2y o F1y. Okay? Are they equal? Yeah. Okay. Given the assumption that they're equal. Okay. So what we're concerned here is ang kaning forces along y. So F along y, dapat 0 siya. Kaya mo float man siya in equilibrium. The sum of the forces F1y, the force exerted by the water, is equal to the weight sa needle. Okay? So weight sa needle going down plus F1y pataas, F2y pataas. So this is the same naman sila 2Fy. Now, weight sa needle is equal to Fy, and we know Fy siya, if you use this theta here, is a cosine function. Okay? Naman diri ang imong angle sa cosine function. Okay? So, what is F? From the expression, F is just gamma D. And the angle, is it 0 degrees? I see. So, it's 0 degrees because i-approximate ng F1. Ang F1, ang angle, that F1 hanggang F1y are almost aligned. So, the angle between them is 0. Okay? Approximately. So small. So, that cosine theta is equal to 1, okay? Or theta goes to 0. So that means the weight of the needle is equal to 4.672 times 10 to the negative 3 newtons. And that's it. So I hope you learned something new today. Ingat and God bless.